Thank you very much, and welcome, and have a good afternoon. I'll tell you a little bit about the future of flying here. I see it's 13 minutes, so I'll have to rush as I planned for 15. Just to put you into scene of what is ahead of us and what is at stake, basically, I brought with me a couple of figures. In terms of growing demand, we have ahead of us for the next 20 years, we're estimating an additional demand of 39,000 additional aircraft, which is quite significant. 60% of that is actually growth, and that growth is actually coming from emerging countries. So these are countries which today do not fly that much, where aviation has not picked up full. For instance, you may see a lot of news that we have from India and also from other markets. But this is areas where, for instance, in India, I heard that roughly 2/3 of the population doesn't hold a passport as of today, but they will in their very near future. And as soon as they do, they will want to fly. So it's not a question whether we will fly or not, and it's not a matter of it will be a growing demand that we have. But the key point and the key concern that we're facing and that we're having to deal with is how can we decarbonize? So it's a growing sector that we're in. It's good, it's needed, it's required, but how can we decarbonize in the future? A little bit of history before I come to the future. I promise you I'll be talking majorly about the future. But what is important, if you're not that familiar with aviation, is to know that we have quite a history in this. In the last 30 years alone, we have decarbonized by minus 50% already. And why is that the case? It is because roughly 1/3 of the operating cost of an airline is driven by fuel. And obviously with that, they have a key interest since the beginning of flying to bring down that fuel consumption and to be more efficient. So therefore we have it's basically part of our DNA to decarbonize. So where we are today is that point here in this slide where we have reduced already very significantly. And for instance, the aircraft that we're building today, so every single aircraft we're producing, every day we're producing several aircraft and delivering them. If they're replacing an existing aircraft, it is already 20 to 25% more efficient than the previous generation aircraft. So if you wish, just by simply producing, and if it is replacing an older aircraft, we're already significantly reducing. This is where we are today. Just also to put into perspective, the latest generation aircraft up in the sky, in the current, we have roughly 22,000 aircraft in the air globally. Again, also the previous number was globally, not only Airbus share. We have 22,000 aircraft flying, and only 20% roughly of this is the latest generation aircraft. So replacing the remaining 80% will already significantly bring down the CO2 footprint of aviation. Yet, whilst we're in an increasing demand, we need to also work on many other factors. And as I said, to bring down the remaining 50%, there are several things that we need to do. Whatever I will be telling you, keep one thing in mind, which is really, really important. All the different activities that we're taking and currently developing, they all need to take place in parallel. It's not either this one or that. Is that more favorite or is that more favorite? It all will have to come together in parallel. We cannot afford to even let go of 1%. Some of those activities may sound rather minor. Some of them are really only talking 1% or something. We cannot even let go of 1%. So it really needs to be understood in that way. So what is the main areas of focus that we have? There's a lot we can do immediately, more or less. There's a lot of efficiency increase that we can do, for instance, for flight operations and for flight route optimization and air traffic management. Here, actually, it's not a technical challenge because the aircrafts could do. There's a lot of improvements we could have if we would optimize the ascent and the descent, so basically the route how an aircraft takes off and how it lands, as well as operations at the airport and so on. But that rather is, or the constraining factor is rather regulations. So for instance, we're having undertakings like Single European Sky, where we simply only need, believe me, it's not simple, but where we need to agree about the air traffic management in Europe, which would then allow immediately to put those things into perspective. Roughly it counts for 5 to 10%, this alone, and again, that's something that we really need to push forward, where we in Europe really need to move forward in order to implement, as this would be really the easy, low-hanging fruits, technically completely possible as of today. Another very important and relevant measure is the sustainable aviation fuels. In SAF, we call them. The sustainable aviation fuels, basically, today it's biogene sustainable aviation fuels. They bring down the CO2 emissions by, depends on a little bit how it is being produced, but let's say 80%, maybe a little bit more than this. So very good factor already compared to kerosene. All our Airbus aircraft today, worldwide flying, they could be fueled with up to 50% of this SAF. SAF is a drop-in fuel. That means you can mix it. As much as you can get on the market, you pour into the tank, you add the remainder in terms of kerosene, up to 50%, no problem, no technical changes needed. So very, very efficient and very fast way to decarbonize there in itself. So therefore, obviously, that's a key factor that we have. The next steps here from us as an aircraft manufacturer is to certify even up to 100%, because that's a typical question I have is, okay, great, 50% is tick in the box, but where is the remainder? How can we really come up to 100%? We have committed ourselves that by 2030, we'll have certification ready. Just as a side note, certification and safety is probably in aviation is the highest standards you could find. Even space is less. People are always surprised when I say space is easy compared to commercial aviation, but understandably, the commercial aviation safety standards are extremely high. So by 2030, basically, we will have our aircraft ready and certified that even up to 100% can be fueled by SAF. The problem with the SAF is the availability. So as of today, we're in the range of, let's round the figure to make it really sound big, it's 1%. So that's why when I tell people, and we'll be ready with 100% by 2030, I keep telling also people, don't worry about the certification point, we'll take care. It's a challenge, but we really need to ramp up the SAF availability, very obvious. So here, right now it's in the biogene area, but really to come to, let's say, representative demands and scale, we need to look into power to liquid. Power to liquid is basically hydrogen-based, so we'll be right back to the discussion of the forums here. And that needs to be ramped up. We are here in Europe, our regulations, there's a lot of discussions, what should be the right quotas. I think we're right now in EU now having agreed roughly for 6% by 2030. We from Airbus believe that's not enough. We need to be faster, because in order to really to create or to increase significant the availability, the demand needs to much faster go up. For that reason, we're taking action ourselves. Obviously, we're flying. I mean, we're an aircraft manufacturer, so we're not operating it. I always need to remind people we're not the airline themselves, that's others. But we're obviously also flying our aircraft. We're testing them. We have our transport aircraft, the Beluga. So we're taking a step to lead by example. And this year alone already, we have set the target to use 10% SAF for our internal flights, test flights, customer flights, and all of that. And by 2025, we even want to increase, and we have set ourselves a very challenging target to come up to even 30%. Again, the key driver for us, I mean, there is associated cost as well, of course, but for us, it's really to accelerate the production of SAF, and that's why we believe it's needed, but it is very challenging to supply it at the same time. So that's the category of SAF. I told you there are several elements that need to go into parallel. And then there's a lot of product-related aircraft, and I think that's the main reason why I'm on stage here today. So what are we doing about our aircraft? There's a lot of efficiencies we need to gain in terms of technology. to bring down fuel consumption, but also, obviously, to counterbalance the additional cost. When we'll talk about hydrogen, or even if we talk about SAF, obviously, the fuel, whatever it is, will go further up. So therefore, our aircraft will have to be even more efficient. So we're putting a lot of efforts into new technologies, be it we're looking into the wings, and actually we're here comparing with what we see by Mother Nature, where we're looking into birds, how their wings are shaped and so on. So that's a lot of efforts we're taking. On top of that, that's normal, no matter what aircraft type and no matter what the combustion is. So we'll look in it for all aircraft types. But on top, what we're looking into is really different fuel consumption. And here we're coming really to the key point of hydrogen. So what we have set as Airbus as a target is by 2035, we want to bring to market the first hydrogen aircraft in that range. We're talking regional range, roughly, something like 1,500 nautical miles. By the way, that is actually out of the demand. I was talking 3/4 of the demand is driven by that region, so we're hitting right on the market and on the demand. And the target is to have it, obviously, hydrogen fueled, either by combustion, and it's not yet decided, or by fuel cell, or a combination, a hybrid from both of them. And this is the undertaking we're having. It's called Zero Emission Aircraft, ZERO-E in brief. Today we have several concept planes, so don't be confused if you see different pictures. There is different concept planes we have and we're working on, but today we have not yet decided how exactly it will look like. Currently we're rather focusing on what we call the technology bricks. So the technology bricks basically is what the key elements, components of an aircraft is made by. So for instance, I talked about combustion. The fuel cell is a key centerpiece of the zero emission. The perfect solution of a hydrogen-based aircraft would be a fuel cell-based aircraft. So that's one of our key objectives. As I said, it could in the end also be combustion, normal engine combustion, but then with hydrogen-based. But for this fuel cell, we created a joint venture. So we're building on a lot of automotive knowledge there. But we have to take it to a whole different level. In aviation, obviously, weight is a key concern. In the end, it will still have to be lifted up in the air. And therefore, the power density of the fuel cells will have to be at a whole different level. So for that reason, I just made a calculation a couple of weeks ago, just as just for fun, basically. What would it take? How many engines, truck engines, fuel cell engines would it require in order to lift up our aircraft? We're talking megawatt here. And how heavy would it be? And how big it would be? And the end solution, I'm not going to give you numbers, but was basically it's more or less eating up the complete space of the aircraft. And it's so heavy that would probably not even take off. It would be too heavy and you could only drive it. Obviously, that doesn't work in aviation. And that is just the explanation why we're having to really do a lot of research and development in the area of fuel cells. The tanks are also quite a challenge. It's another technology brick that we're looking at. We're talking liquid hydrogen, so therefore minus 253 degrees, which is pretty cold, and the thermal management associated is quite challenging as well. So these are just a couple of examples of those technology bricks that we're looking into, which we're further maturing, and then in the next couple of years, basically by 2026, we'll be flying a lot of those elements. So you see here in the picture, in the lower picture of the slide, you see an A380. The A380, it will be really physically an A380 aircraft, actually one of our first test aircraft that we ever built, will be used as a flying test bed. Why A380? Is because we'll put an extra engine on there, if probably a fuel cell engine at one point, but we'll also test a combustion engine on it. We'll have to put liquid hydrogen tanks in there, and obviously we'll still have to fly it. So what it will look like, if you have never seen a test bed, a flying test bed, it looks a little bit as if your kids have played around with Photoshop, because you just simply attach an additional engine there, and a fifth engine outside of the aircraft, which will then be run on. And we'll try out by 26 several of those configurations, several of those different elements. We'll put a hydrogen tank in context with a fuel cell, but as well with normal combustion and so on. And then by 2028 is more or less the year that you can mark already in your calendar when we will then finally decide on how the concept aircraft itself will, which one we will take. So by then we will decide how it will look like. And a lot of the elements will have an influence on that. You can imagine the tanks will be pretty big, and they will no longer be in the wings, obviously. That doesn't work with liquid hydrogen. And for that reason, that will have also an influence on the shape of the aircraft itself. So just to mark a little bit the journey until 2035, those are the key milestones we're looking into. And the remaining time will be basically then the pre-program phase, where it's about really putting different technology bricks into context, but as well, or the most relevant is the certification itself, which is quite a challenge in aviation itself. What will have to take place in parallel, and I think that that's a really interesting element here for this audience, where we're also looking into other sectors, or where we're collaborating with many other sectors, is by then, by 2035, the first airlines will operate this hydrogen-based aircraft. We'll have to make sure that we have put up the hydrogen ecosystem and infrastructure worldwide. You will not find an airline that will be willing to buy aircraft that they can only operate between Munich and Paris. That will not work, obviously. So therefore, we'll have to make sure that we really have a global network, that we have airports that are ready, that we have the green hydrogen available worldwide on those hubs, for instance. And that we have set up this infrastructure. 12 years is not very long for that. Just to give you a reference again, it took 15 years to bring up this infrastructure for kerosene. And kerosene is, I would say, in many respects, easier than hydrogen. So here we're really looking into collaborations, how we can realize that. We're an aircraft manufacturer, but we decided roughly 1.5 years ago that things are not taking place fast enough, and very clearly speaking, we will not launch our aircraft if we're not sure that by 2035 the infrastructure is ready. You can imagine that no airline will buy an aircraft where they're not certain that they can operate it. So that's why we decided 1.5 years ago to take a much more active role. And we're bringing together, really, we're facilitating a lot. We're putting up cooperations with energy providers, with governments, because we're talking a lot of regulations, a lot of research that still needs to be done around liquid hydrogen in aviation in order to meet the safety standards. We're bringing together, obviously, airports themselves, investors, all the key players in order to make that go live. What we have created, and you see it at the bottom of the slide on the right side, a network worldwide about hydrogen hubs. So basically, and don't worry about the picture. Don't take a photo because it's evolving. It's probably already outdated today because it's growing. But it's just representative to say we look into such hubs worldwide, which have different conditions, they have different constraints, they have different local requirements that need to be fulfilled. But with this, we are trying to build basically a map of very different conditions that represent, in the end, all what we need worldwide. So you will have regions that will have the green energy and the green hydrogen available right on the spot, and there's others where the majority will have to import it. You'll have some areas that will get it by pipeline, others will have to get it by truck. You'll have, even in terms of governmental constraints, very different constraints as well. So this is what we're building with those hubs. You could call it lighthouses. So we're creating those lighthouses that can then be very representative role models in order to be launch ready for implementation worldwide. So this is where we're largely engaging, and actually where we're putting a lot of push into, because again, 12 years is not much. We have a lot to do on our side in the 12 years to mature the technology, but at the same time, we really need to get going. The pacemakers is not only the infrastructure itself, a lot of it will also be regulations, governmental work, and so on. So this is basically, I'm coming to the end. I hope you got a good impression of what the challenges are ahead, but as well also what is the opportunities and the beauty of it. The challenges are so high, but I see that we have a lot in common what we heard earlier. So we're really teaming up in the best interest to bring things very fast forward with maritime, with truck manufacturers and so on, as we all seem to have similar, or some of the challenges we have are very similar ones. And that makes us, or me personally, very enthusiastic and very motivated, because I feel that there is a momentum right now where everybody is really willing and ready to bring things to the table in order to move forward fast, because we're running out of time. And it's not, and maybe that's the last sentence, it's not a matter for us, Airbus, to be market leader. It's not, we are market leader and we want to remain market leader. But I think that's not the biggest motivation. We're running against the time. I think that's the biggest motivation. So we really need to make sure that things are taking place at the time which is planned, simply because 2050 is soon and we need to decarbonize by then. Thank you very much for listening.